If you can find the area of a rectangle and the area of a triangle, you are in a fantastic position now to go ahead and find the area of our next shape, the trapezium. Trapeziums are very similar to our shapes from M104, the parallelogram. They're both quadrilaterals, i.e. they have 4 sides, and they both have parallel sides. The only difference is parallelograms have 2 pairs of parallel sides, whereas a trapezium only has 1. When teaching students about trapeziums, lots of them like to try and break it down. They find the area by finding a rectangle and a triangle and piecing these together as a compound shape to find the area of the trapezium. Now this is absolutely valid and they do get the right answer. However, we're going to look at some compound shapes a bit more in video M106. Right now, I'd like us to look at a trapezium as its own shape. Using the method we've used all along, the grid we'd create, multiplying the height by the base, would give us this. Now there's a missing space, a bit extra. However, if we were to cut down the grid a little bit, we can see that now there's a bit too much grid here and not quite enough of it here. And it balances out. This little triangle bit poking out can fit perfectly into this gap, and so the grid is actually the same size as the area. The question is then, how far do we have to shrink the base in order to make this work? The answer is to find the midpoint exactly between the length of the bottom and the length of the top, between the 2 parallel sides. If we call the lengths A and B, we find the halfway point by adding these together and dividing it by 2. And once we have that, all we do is, as per normal, multiply it by the height. For example, if the base was 6 centimeters and its parallel side was 4 centimeters, we add them together, 6 add 4 gives us 10, and then divide it by 2 to get 5. Our midpoint is 5 centimeters. We then multiply that by our height, in this case that's 3 centimeters, to get an area of 15 centimeters squared. And there we've done it. In essence, we've added the parallel sides, A and B, divided it by 2, and multiplied that by the height. I'll leave the formula here for you. Can you use it to find the areas of these? Pause the video and have a go. Let's look over the answers. The first has A and B values, that's the parallel sides, of 1 and 3. We add them to make 4 and then halve this to make 2. This times the height, 4, is 8 centimeters squared. The second shape, B, has A and B values of 5 and 7. We add them to make 12, halve it to make 6, and multiply this by the height to get 18 centimeters squared. Finally, in shape C, we have 4 and 10, which gives us 14. Half of this is 7, and then multiply this by the height of 3 centimeters to get 21 centimeters squared. Just to reiterate for you, we're looking for the midpoint between sides A and B, the parallel sides, and we do that by adding them together and dividing by 2. Once we have that midpoint, we just multiply it by the height, same as always. Assuming that was no problem for you, you are absolutely ready to go on to M106, where we're putting some of these different areas together in compound shapes. Of course, if you struggled, don't worry, you can go back and watch the video again and go and find a teacher. Bother them till you're blue in the face.